Reynolds theorem that says if two are congruent, then you know this one's also congruent. Right? Well, we didn't talk about similarity yet. So I said, do you agree that it's a postulate and not a theorem? Do you remember the difference between postulates and theorems? Yeah, a postulate's is accepted without proof. Like there's no formal proof for a postulate because they say it just makes sense. Makes sense. Right? There's no proof for it. I feel like we could sort of prove it by the third angle theorem, but whatever. Moving on. It's kind of cool one because now when it says determine whether the triangles are similar, if so, write a similarity statement. Explain how you know. So look at number 1 and number 2 for a minute and see if you can decide yes or no. Do you have enough information to determine if those are similar? So that second one there, these are marked with triangles. What does that mean again? Parallel lines. Probably you're supposed to do something in. First one. Let me say no because just look at it. Maybe it is no. I don't know. Maybe I'm lying. If I get this lead here. Parker did. He likes to the calendar days getting marked off for our different directions. Sydney, how could I find what angle A is? If you do that, what do you get? So based on that, is that enough information to say they're similar? Because now 42 and 42 are congruent, 80 and 80 are congruent, which means this is also going to be 58. Sure. Yes. So, are they similar? Yes. So if I said triangle ABC, what would I have to say that's similar to? E, B. Remember, order matters. Explain your reasoning. You would want to say, I would just say angle A equals 80 degrees. So by angle, what was that called? Angle. What about number 2? They don't give me any angles. Can I prove that these angles are congruent? We definitely could use vertical angles. So angle QXC is congruent to angle NXM by vertical angles. It does say explain your reasoning, right? You need to say vertical angles, how you know that. And then because they give you parallel lines, you could use alternate interior angles. And remember, you don't really have to prove all 3, but we could prove all 3. Because these would be alternate interior. Well, we just have to prove 2, right? Because then we can say by angle. So I can say angle Q is congruent to angle N because of alternate interior angles. See how explain your reasoning is kind of like being proof. Let's take a look. So, yes, triangle QPX is similar to triangle I think the X has to go NMX by the angle similarity. again, how we can show or prove that triangles are similar. It says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if you know the side lengths are proportional, but you don't know anything about the angles, then that's enough, is what that's saying. So if you know all the scale factor is the same, Chandler, stop, then that's enough. Also, side angle side. Oh my goodness, all these things are coming back to us. If you know two sides are proportional and the angle in between them. So notice it's really specific here. RS over XY is the same as ST over YZ, right? So the two sides and the angle in between, right? Not angle side side, but side angle side. So again, lots of ways to prove things are similar. So I'm going to give you a minute to look at these and see what you can come up with. When they give you all three sides, you read it, it makes sense for side side. Or you just read it. Why would side angle side be better? You definitely could show right here that these two angles are congruent, but you could also, they give you all three sides, so you could do side 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 here, but we could say that angle ACB is congruent to angle BC. Is that true? Sometimes I have to redraw these. I'm not a very visual person sometimes, and I have to redraw the things. Because of vertical angles. And then I'm going to check the ratio of the sides. So I'm going to say 6. Which side would 6 go in? Like this, you can take this and flip it over like that. Because 4 is smaller than 5, and 6 is smaller than 5. So 6 is going to go with 4. Is that equal to, which other side do you have to check? Well, if you're doing side angle side, which side do you have to take? Yeah, so if you want to do side angle side, you have to do the other side that's in between. If you want to do side side side, you can just do all three. 7.5 times 4. You know that way of checking two things are congruent? Because like you can say 6 times 5 is 30, or 4 times 7.5 is 30. If those are equal, then it's a condition. Or you can just write that. So since those are equal, we could say by side, angle side, that they are similar. We put the sides. So the triangle ACB is similar to triangle Why do we only have to check the ratio of two sides? Because Audrey, said we should use the side angle side one. Because if you can prove, right, so you had options. If you didn't want to do the vertical angles and you just checked 9 over 6, it should still work out that it's all the same. So you could have said side angle side or side 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 on that one, depending on what you checked. Okay? But that's why we only check 2. What about this one? What are even my 2 triangles? So definitely one triangle is NMP, right? And so it's 10 and 12, we don't know MP. But then it's the big one, right? So if it helps, you could separate it like this. and it's triangle RMS. So you have to think about that RM, the whole triangle there is 25, right? That's tricky.
It can also be triangle RS midpoint. So
What?
RS is the midpoint, maybe?
No, there's no midpoint in their label, so we have to use what's there. No. So just be aware, right? That I thought that might trip us up a little bit. So if it helps you, you can break them up like this. Can we do side, side, side on this one? Do we know all three sides of the triangles? Which means we have to show this by side angle side. Which angle do we know is congruent to another angle in that triangle? M, because why? It's the same angle. It's like the reflexive property if you were going to write that proof out. As we know, angle M is congruent to angle M by the reflexive property. So they like to give you that triangle and a triangle because you get that one angle that you know is congruent. So then you need to prove that the side lengths, and that's where you have to think about the big triangle is not side length 15, it's the whole triangle together. So is that the same ratio? Is 10 over 25 the same ratio as 12 over 30? Or we could just simplify it and say that divided by 6 is 2 over 5, right? Either way, however you get it. But they are the same ratio, which means that we can say, yes, they are similar by side, angle, side. And then you write the similarity statement. Okay? I'm out of room. So I kind of wrote them out already here. Triangle NMP is similar to triangle RMS.
RMS.
I don't follow. What kind of shit? Hey, if you have your book open, you should find this chart and fill it in.
You know how the Titanic beach? They're also arguments.
Oh, I'm not a shit. You said you were doing college stuff. You lied.
I was.
Turn it off. Put it up.
So I have this. Get it?
So basically, these properties are saying the reflective, the symmetric, and the transitive properties that we've been using with equal sign and with congruent sign are true for also similarities. So we can say triangle ABC is similar to triangle ABC. Symmetric says you can flip the order around. Just to remind you, it's been a while. You don't forget that. So that if that's true, right, and say if, then triangle BF is similar to triangle A. And our good old transitive property, that's a whole lot of writing. Oh, We use these properties all the time, and geometry is really the one class that we teach you that. So as you move on and you're solving equations in other classes, like these properties, along with all the other properties, you can show up. So now it says given that RS is parallel to UT, and they give you all this stuff. I think it's labeled for us already though. RS is 4, RQ is x plus 3, QT QT is 2x plus 10, UT is 10. Find RQ and QT. Step 1, we can't do this unless we know they're similar, because we showed these are similar. They don't tell us they're similar.
They're parallel.
So they're parallel, which means we could use our alternate interior angles, right? So we know this angle and this angle are alternate interior angles. And we know that this angle and this angle are alternate interior angles. Parallel lines. When you see parallel lines, you can use alternate interior angles with your triangles. And we don't even need the angle-angle similarity that says if two angles are congruent, then the third one is, because we also could use vertical angles there to prove those are congruent. So you need to say that first. So we need to say that we know triangle RQS is congruent to triangle UQT. Doesn't matter.
So,
You hear what they're saying there? Kind of important of knowing which one goes with which when it splits like that is we match the angles up, right? So RQS, I have 2, 3, 1 marked, so that's how you know it's TQU. And I'm just going to put by angle similarity. Then if I know they're similar, oh my gosh, I gotta do this. If I know they're similar, guys, then you can set up a just like you do, right? Because we know, you want to do 10 to 4 or 4 to 10? So if I say the ratio of UT over RS, then I could say TQ and RQ, right? So then I can say 2x plus 10 over x plus 2. The extra part today is yesterday they told us they were similar. They just didn't tell us. Today you have to tell me why they're similar first, and then you can solve it. So I'm going to say 10x plus 30 equals 8x plus 40. Just cross multiplying and distributing all at once. So if you subtract 8x over, you would get 2x. If you subtract 30, you would get 10. So x equals 5. Am I done with this problem? No. Right? It doesn't say find x. It says find RQ and QT. So just don't forget to go back and do that. RQ is x plus 3, so 5 plus 3 is 8. And QT is 2 times 5 is 10 plus 10 is 20. The whole board was fine. Not really, but that's why the angles are different. Unless you're
Don't
Leo
play.
Ortega is funny.
Don't play.
So I think you can read over this number 5 at the bottom there. It's a story problem, but I think if you can't read part A, it says right at the portion that can be used to determine the height of the house. And then part B says what is the height of the house. Draw pictures. Or ask you to take from your book for that. And then on the back, some really just one problem, but there's part A and B. So one problem, and then part A and B to solve it. And then number 7, I want you to make up a real-life problem, right? Write your own problem that can be solved using similar cycles. Which means don't just take the one on the front and change the name, right? Like, don't be like, I want a house cat with 148 potatoes. You could be like, a building cat with 148 potatoes. Be creative.
Yo, I think this is logical stuff. And that's come on, let's break, you know? Not that right.
Okay, I'm going to work on this.